we hopefully you remember what CALM stands for. It's the underlying values associated with DevOps, and it can be applied, of course, to security in DevOps. So the acronym stands for culture, automation, lean, measurement, and sharing. So these statements are how to interpret those values for security. So culture, all technology teams have accountability for security. So not just the security department. Security is everybody's job. All understand the end-to-end system and collaborate regularly to create trust. So that's an important word. With security, you want to accomplish a level of trust. But ironically, part of the way you do that is have kind of a inquisitive mindset where you don't out of the box just trust everything. You verify it, and then you, through verification, accomplish trust. Automation clearly is critical to DevSecOps. There's no way you can do all of these security checks manually and keep up with the speed of DevOps deliveries. So automation helps assure security by strategic use of codifying, orchestration, automation of tasks and processes that have security vulnerabilities when done manually, and where automation can enhance security practices. So certainly as you get more and more mature DevSecOps with solutions, you're going to see more and more of that being automated. And recently with Gen AI and AI solutions, but overall just through tools and automation. Lean is all about trying to make sure you don't have security as a bottleneck. It's not a constraint in the value stream. You shouldn't have some big choke point where you're doing all the security checks. Instead, build security checks along the way and automated so that you're not waiting for security activities to happen. The flow of work from development to production should be smooth without a lot of friction. Work should be visible through shared backlogs. So everybody in the associated with the value stream, all the stakeholders should be able to see what's happening. Measurements. So probably the most important thing here is understanding when breaches occur, what's the impact on your business, the metrics, make sure those are shared. Everybody can see what's going on and contribute to solutions because they see what's going on, and have a value stream centric approach, looking at what's the most important things to have security around. Again, there's no such thing as 100% security. So you need to be very clear-eyed of what you're going to optimize around, making sure there's no delays caused by security. You don't want to have a high-speed, fast lead time DevOps environment only to be held up by security. So that doesn't mean you don't want the security, of course, but it does mean that you need to build security in and make sure it's quick. And finally, sharing, where security and software engineers cross-skill, collaborate to help build their knowledge around security automation, share stories, share documents through wiki pages, for example, have stand-ups that are together and working together on a day-to-day basis. Quite often I see security experts working together with developers, either doing cross-training or helping out with tasks, maybe defining what some of the tests should be, or maybe how to tune certain checkers and scanners to match best whatever the perceived threats are for that application. Okay, again, going back to the 3 ways, which the underlying 3 principles of DevOps. The first way you may recall is depicted in this little diagram, the idea of having flow of software changes from development to production or operations with minimal friction. That's what that's all about. When you think about flow from the point of view of security, it means ensuring the security is not a constraint in the flow of work. Shifting security testing as far left as possible is an example. Try to do scanning right up front. Don't wait till the end and then have a problem. Automate as many of the security checks as possible. For example, you could have things like scanners that are already scanned that you're reusing, without having to do that again. Think like a value stream. Meaning you want to look at all stages in the value stream. It just looks like a line in this diagram, but there's a lot of different steps involved. Great accountability across the value stream, but also be prepared to share tasks when needed to keep things moving on. The second way is all about feedback. It's called feedback. you want to amplify feedback loop is represented by this backward facing arrow, where the flow is measured at different points, and that information of measurement is used to help improve flow. So you're ensuring fast feedback, automate security checking, for example, include security early in the process, including product demos, security teams, creating continuous peer-to-peer conversations, using telemetry, observability, building in the ability to see what's going on from a security point of view in your products and pipelines. And of course, the third way of DevOps is about continuous experimentation and learning. It's represented by these little squiggly circles in the middle of the diagram. Once you have a strong, working flow and feedback, you can use that information and that automation to improve and optimize things. So you never really accomplish a final DevSecOps. You're constantly looking for improvements, partly because the threats are going to evolve over time, but you're going to be constantly looking out for new solutions. So ensuring that security people and software engineers are cross-skilling on an ongoing basis, allocate time for them to sit and work together, learn from each other, encourage documenting and sharing experiences, good and bad, not only within an organization, but also reaching out to see what's going on in the industry. Attending conferences is a good idea, or other meetups or DevSecOps or DevOps days, things like that. Okay. In my book, this is one of my books, Continuous Testing, Quality, Security, and Feedback. I emphasize 8 different principles. First one is DevSecOps culture, ensuring collaboration between development, security, and ops, help understand desirable security outcomes, having security awareness and training, sharing responsibility, helping each other learn, security integration in the life cycle. So build security into the whole life cycle, not just an isolated stage. Automating security testing. Often testing is a big bottleneck if you don't automate it. Not just the execution of tests, but also the analysis of the results. Automating is key to maintain security vigilance. You can do things, get more checks done through automation than if you were to do it manually. Proactive risk management, so identifying and mitigating risks to be more effective than just reactive measures where you're responding to security events. Having rapid incident response, certainly there will be incidents despite your best efforts of being quick and effective to respond, putting in place automation and playbooks, for example. Continuous monitoring compliance, so you can see what's going on in production and also, in pre-production, from a security point of view, making sure you're compliant. You've got measures for that, and make sure that you're maintaining at least your minimum security profile, which again can evolve over time by itself. Regulations change and threats change. Feedback and continuous improvement is the last bullet here. Basically, it says feedback is essential to be able to evolve and improve security over time. Yeah, actually, this is also out of my book, but it's the same idea. There's no such thing as a standard DevSecOps capability maturity model, but this is an example of one that I think makes sense. So at level 1, you have manual and unmeasured DevSecOps, kind of a chaotic situation. Not unusual to see organizations starting out at this level. You got fairly limited security awareness in the development team. Collaboration is happening, but maybe not very well with security specifically. They have somewhat ad hoc processes, perhaps some tools, pretty basic ones, and minimal metrics. That's roughly what level 1 looks like. Again, these are not hard standards, so you may find some things are at different levels than others. Level 2 is really building security into the continuous integration portion of your value stream for an application. So there's more collaboration going on between security. You have integration of security checks during CI, so you may have software composition analysis scanning, source scanning for security, and maybe dynamic scanning, some basic automated testing and metrics for vulnerability identification during CI, so prior to CD. And then, the next level would be to build it into CD, do your major testing phases, enhancing collaboration across the different testing environments, more fully integrating security checks into testing and prior to deployment, different processes, more advanced assessment tools. Well, might be looking at penetration testing results, ethical hacking, security, chaos engineering type things. So a little more advanced practices around security and having more comprehensive security metrics. So that's what level 3 would look like. And level 4 is where you actually are deploying automatically to production. So you automate the last leg in the pipeline, if you like. So there's a strong focus here on security and deployment. Policy as code would include security practices and security measures, automating those processes, really having good monitoring in place, especially when you're during deployment. If you have to back up, having that in an automated fashion as much as possible through progressive deployments, having detailed methods and metrics to enable rapid response as you're releasing in an automated fashion. You can do that quite regularly and quickly, so you need to be able to react quickly if the problem occurs. And the final level, which is really, the most mature level, at least in the way this model is represented, is really a measure of continuous improvement. So we call it continuous operations, operations-wide commitment to security, unified processes, continuous monitoring tools in production, hopefully consistent with the ones that are being used in development, more advanced metrics, such as time to resolve, security events, and things like that. So essentially all in with DevSecOps at that point.